Problem number 1 in exercise 6.4 tells us that each of 3 people randomly chooses one of these calculus sections, A, B, or C. And part A says, if they do this independently, what is the probability that they all choose the same section? So what's the probability that maybe all 3 choose A, or all 3 choose B, or all 3 choose C? I think there's a couple ways we could look at this. First of all, let's suppose that one of the students makes a selection. Maybe that student selects A. Then what has to happen is that the next 2 students also have to choose A. So what would the probability of the second student choosing A? Well, that would be 1/3, because there's 3 possibilities. And the third person choosing A, that would also be 1/3. So this is going to come out to be 1/9. So what we're just saying is that one of the students makes a choice. The other 2 students have to match that choice. Here's another way to look at this. Suppose that we're going to go with A. What's the probability that all 3 students select A? So the probability that the first student selects A is 1/3, the second choosing A is 1/3, and the third is 1/3. Now they could choose B. What's the probability that they all choose B? Well, that would be 1/3 times 1/3 times 1/3, right? Does that make sense? What's the probability that one of the students, the first student, chooses B? Well, 1 out of 3. Second student chooses B, 1 out of 3. Third one out of B. Now, they also could choose C. So what's the probability that they all choose C? Well, 1/3, 1/3, 1/3. And then what we'll have is this. We could be choosing A or B or C, so we're going to get 1 over 3 times 3 times 3 is 27, plus, for B, this one here, we're going to get another 1 over 27, and plus for C, another 1 over 27. Adding these fractions, we'll add the tops together, getting 3, the bottom's getting 27. That comes out to 1/9. So either way we do it, we get 1/9. Now, in problem number 9, we have an urn that contains 5 red balls and 4 white balls, so a total of 9 balls, and we are going to select 2. And what we want to know here is, what is the probability of getting, and I'm going to write it in English, at least 1 red? Well, sort of English. So when I see these problems that deal with at least 1, I'm going to think how I can get that at least 1 in terms of exactlies. So this is going to be, how do you get at least 1 out of 2? You could get 1 red or 2 reds. And now what I want to do is I want to get these right here in terms of everything I've got in this pot right here. I've got reds and whites. I want to get this in terms of reds and whites. So I can write this, if I do it like this, the probability, I'll use a square bracket here. Now, to get this 1 red, if I'm drawing 2 items, 2 balls, I can get 1 red, I have to get 1 red and 1 white. Then I've got the or, and now what I want is, how do I get these 2 reds, and I want to write it in terms of reds and whites. So to get 2 reds, I must have 2 reds and 0 whites. Close and close. And now, because I have it in this form right here, red and white, and that's what's in my pot up here, I can just write what the count is going to be. So out of 5 reds, we want 1. Let's just look at that, right? We've got 5 reds, and we want 1. And then, for this one right here, I want 1 white, and what I've got here is 4 whites. So out of 4 whites, I want any one of those. And then we have this or here. Now the or, that's going to be a plus. And then we have 2 reds. All right, now how can I get these 2 reds? Well, I have 2 reds. I have 5 from which I can choose. So 5 reds, choose 2. And then there are 4 whites, and we want 0 of those. And now, because this is a probability, we're going to get a denominator. And what is it exactly that we're doing? We are drawing 2 items out of 9. So how many different ways can we do that? That's going to be 9, choose 2. And when I put this on my calculator, I got, let me look here, I got 0.8333 rounded to 4 decimal places.